Hello, welcome to lesson 521. Today we are going to be exploring functions of the exponential form, right? So we've been learning how to find inverses for all different types of functions. So we're going to start talking about how to find inverses for what we call exponential functions, right? Those are functions that look like this, where we have an exponent that is a variable. All right, so we're going to explore that. We're going to take a look at the table, the graph, and then we are going to start working on the equations. All right, so let's start off. We have 3 to the x power here, and I want to generate a table for that, see what it looks like, and then get it graphed, and then we'll do the same thing for its inverse. So over here on my calculator, I'm just going to go ahead and hit that y equals button. That will take me to this entry screen here, and I'm going to take 3 and I'm going to raise it to the x power just like that, right? So 3, and then you hit this little caret key, and then the x button. And I'm going to go right to the table to get my values here. Okay. So we have our table over here starting at -2, so I'm looking at my calculator here. -2 gets us a 0.111, so I'm going to say point. So -2 gets us a value of 0.111. All right, then I go over here and do the same thing. -1 gets me 0.333. And then when we look at 0, we get a 1. 1 gets us a 3, and 2 is going to get us a 9. Right, so there is our table. I'm going to go ahead and graph that. All right, so this first point is at -2, so I'm going to count left 2, and then 0.111 is just going to be right here above the x-axis, just barely above it. Just kind of eyeball those decimal ones. There we go, just like that. And then we're going to go to the next one, -1 and 0.333. So I'm going to go left 1 and 0.33, about the same thing, just above. Just like that, just a little bit higher though. And then our next point's at 0, 1. And then 1, 3. And then 2, 9. So I'm going to go right to 6, 7, so 9 would be like somewhere up here, a little bit off the graph, which is okay. All right, and you start to see this curve forming, and this is what we call an exponential curve. I'm going to try and draw this the best that I can. So it kind of floats there just above the x-axis for a little bit, and then it's going to curve up and go through these points that I plotted. There we go. So there is the graph of f of x. So now I'm going to go back and get my inverse, and remember for the inverse table all we have to do is flip-flop the points. So this is going to be 0.111 and -2. This will be 0.333 and -1. And then we're going to have 1, 0, 3, 1, and 9, 2. So again, just to get that table, all I did was flip-flop the points that we have there. I'm going to switch colors here, and we'll get the inverse graphed on this coordinate plane that we have. So let's go. Okay, so to graph this one, we're going to go right 0.111, right, which is just barely right of the y-axis, and then down 2. So we're looking at this point right here. And then we're going to go 0.333 down 1, so right 0.33, just a little bit further to the right, and then down 1, so be about right there. And again, sometimes with these decimal points, you just kind of eyeball them. Right? And then 1, 0, 3, 1, so I'm going to go 1, 2, 3, up 1. And then this last point is at 9, 2, so we're going to go 1, 2, 3, 4, 5, 6, 7, so 8 and 9 would be kind of out here, and then up 2 would be about right here. So you see that same kind of curve, and I'll draw the curve through this one again. Again, it kind of just floats just to the right of the y-axis, and then we curve through these points like that. Right? And I'm going to put arrows on both ends. And you'll notice that line of reflection, just like we saw on all of the other functions that we explored. When we graph the function and its inverse, we see that line of symmetry exactly on this line, right? This is the line y equals x, and we see that reflection, which is really good, right? So that's the table and the graph for an exponential function. Let's start exploring the equation a little bit as well. Okay, so what we had learned last week was that we could find the inverse by making x and y switch places. So instead of writing this with an f of x, I'm going to write this with just a y. So we're going to say y equals 3 to the x, and then I'm going to use my switch and solve method, right? So I'm going to write this with x and y switching places. So we get x equals 3 to the y power. And then this presents an issue because we've never solved an equation, right? The next step here would be to solve for y, but we've never solved an equation where y is in the exponent, and frankly, we don't know how to do that, right? So the question is, how do I do it? How do I solve for y? Okay. And that's what we're going to explore in today's lesson, all right? Hypothetically, let's say that we knew x was 81 here, right? So instead of putting an x there, let's say we knew that 81 was the value for x, and we still have this 3 to the y. Could we figure out what y is? And yes, we could. We could actually guess what exponent would go up here. So for instance, I can go over to my calculator and just do a little bit of trial and error. Okay, so for instance, I could say, let's try 3 to the second power, right? If I do 3 to the second power, I get 9. Well, we need 81, so maybe 3 to the third power. And we try it again. We say, okay, well, that's 27. It's getting bigger, so let's try the next one. Let's do 3 to the fourth power. And there we go, we get 81. So using a little bit of trial and error, we could figure out what that y value is supposed to be, right? So we can say, well, y equals 4. And we're going to use this idea of a number being raised to another power to get another number. We're going to use this relationship to help us understand something called a log. All right, and I don't want you to get all intimidated by this thing. This is called a logarithm, and a logarithm is simply another way to rewrite an exponential function. So we have to kind of think of this like a puzzle. All right, and it's just an exponent rewritten, and there's a relationship between the three numbers that we see with this log expression. All right, so for instance, this first one, you'll notice this little number down here, we call that the base. And so this is called the base. So if I'm going to take my log and I'm going to write it as an exponent, I'm going to say 2 to some power. Right, and then so we have a 3 and an 8 here. Well, it makes sense. If I take 2 to the third power, we get 8. Okay, so really this is just a fancy way of writing this. Right, this is an expression that we're used to. This is one that we're not used to, but they are equivalent in their meaning. Okay, so 2 to the third equals 8 is the same thing as saying log base 2 of 8 equals 3. Right, and we can apply the same thing over here. The base is 3, and then the number on the other side of the equal sign here is our exponent. So I'm going to say 3 to the third must equal this number that's over here next to that little 3. Right, so that's going to be 3 to the third equals 27. Right, so we can do it again here. So notice that we have 5 as our base. So I'm going to say 5 raised to this number, whatever is over here on the other side of the equal sign. So that's going to be 2. So 5 squared must equal 25. Right, that would be the number that we say is inside the log. All right, and then we're going to do it one more time here. So notice that our base, right, this number down here is 10. And this number over here on the other side of the equal sign, that's our exponent, right? So we kind of swing around to the other side to get our exponent. So we say 10 to the fourth equals, and then we swing back around to that number that's inside the log, and we say, well, 10 to the fourth must equal 10,000, which it does. Right, so all these expressions that are written here in pink are all equivalent to what we call these log expressions up here that were given to us. Okay, and this little maneuver that I'm doing here with the arrows, I like to call that the circle of life, and it's kind of my guide to taking a log expression and rewriting it in this exponential form. Right, so we call this log form, exponential form, and we use the circle of life to transform between the two. All right, so let's see how this becomes useful. All right, so you'll notice I have a log expression. Notice that I don't know what number is over here, so I'm just going to put an x there. All right, so we have an unknown piece of the puzzle. All right, and I know that this is a log expression, so I can rewrite it as an exponent. So I'm going to say, well, my base is 2, and I'm going to use my circle of life. So I'm going to say 2 to what power? Well, x, we don't know what that is yet, must equal 16. Okay, so I took my log expression, I rewrote it as an exponent, and now I'm going to go to my calculator. I'm just going to experiment a little bit with this expression. So I'm going to say 2 to some power. So I'm just going to try a power out. Let's do 2 to the third and see what we get. And we get 8. All right, so that didn't work, so I might try another one. Let's say 2 to the fourth. And there we go, and we get 16, which is what we wanted. So we can figure out that x must be 4. So using our circle of life, we can actually find the missing pieces of this puzzle. So let's try it again here. So we got log base 2 of 32, and the missing piece is over here on the other side of the equal sign. So I'm going to rewrite this using my circle of life. Okay, so I'm going to say 2 to the x power, right? So we swing around, and then we come back to the 32. So we got to say 2 to some power equals 32. And I'd go over here and say, okay, well, 2 to the fourth was 16. Let's try 2 to the fifth. And there it is. So we find out that x must be 5. Okay. So notice here the missing piece is the base, right? So we can think of that as our x value. So I'm going to say x, right, is our base. I'm going to use my circle of life to rewrite. Just like this. I'm going to say x to the second power must equal 100. Right, so we say x squared equals 100. Well, we can figure out what that is, right? So if I try something raised to the second power, the number that you would raise to the second power to get 100 is 10. Right, so we'd say x equals 10. And you can test it out just the same way, right? So you can do 10 to, oops. So you can say 10 to the second. There we go. And you see you get your 100. All right. So here the x is in this part of the puzzle, right? So this is the number that goes inside the log. So we're going to say circle of life, right? My base is 5. 5 to what power? The third power. Must equal what? Well, it must equal x. All right, and this is pretty easy. I can go right to my calculator and I can type in 5 to the third. And we find that it's 125. Right. So again, the missing piece is the base this time, so I'm going to say x, that's my base. We're going to raise it to the fourth power, and this must equal 81. Okay. Again, you might have to experiment a little bit, figure out what power or what number you would raise to the fourth power to get 81. So like if you tried 2 to the fourth power, you might do a little bit of trial and error, and that's okay. But 2 to the fourth is 16, so maybe you try 3 to the fourth, and you get 81, so that's our number there. So we find out that x equals 3, right? That's the number that goes down here. And we'll do this last one here. So we got our base of 100, our missing piece is over here, so we're going to say 100 raised to some power equals 10. And this is a little bit weird, right? Because normally when you raise something to a power, you get a number that's bigger. So when you get something that's smaller, you're going to have an exponent that's smaller than 1. Right, so in this case, it's going to be 0.5. Right, so if I do 100 raised to the 0.5 power, you get 10. Okay, so that's a quick crash course is using logarithms to find missing pieces of the puzzle by going back and forth between the two forms. So let's use that. Let's use that relationship on our inverse equation that we wrote before. So remember we did the xy switch. Now I want to take this thing and I want to write it as a logarithm and see what happens here. So remember, when we write a log, there's essentially 3 pieces. There's the base, the number inside the log, and the number on the other side of the equal sign. So remember, the base is the number that's being raised to a power, so this time the base is going to be 3. We would say 3 to the y power, so the exponent always goes over here on the other side of the equal sign, so this is where I'm going to put my y, and we say 3 to the y must equal x. So we took our inverse equation that we came up with by switching x and y, and we rewrote it in its log form. And look at what happened. We are now solved for y. So this becomes my inverse, right? So I can rewrite this f inverse of x equals log base 3 of x. There's my inverse function. Okay. We just figured out here, and I just put this into the notes, and you might want to write this down, is that we can find the inverse of an exponential function by rewriting it in its log form. All right. So let's just get a little bit more practice here, going from exponential form to log form, or log form back to exponential form. All right, so again, this is something that's written in exponential form because I can see the exponent of 4 over here. So if I wanted to write this as a log, I always do it like this. I always say log. There's a blank for my base. There's a blank for the number that goes in the log. And then there's a blank over here on the other side of the equal sign. The base is the number that is being raised to a power, so that's going to be 2. The power goes on the other side of the equal sign. And then we say 2 to the 4th must equal 16. Again, using my circle of life to make sure that the pieces are in the right place. All right, so we do the same thing for this one, very much like our problem that we were dealing with when we did our inverse here. All right, so I have a log, 3 blanks, the base is 5, the power is y, and it has to equal x. So log base 5 of x equals y. Okay. Again, use your circle of life to double check those. So let's do it again, right? So again, writing a log, because we're starting in exponential form, base, input, output, okay? So 2 is the base, exponent is x, and that input's going to be y. All right, 2 to the x equals y. All right, do it one more time over here. So we've got log, base, input, output. The base is 2. The power is -1, and that input's going to be 0.5. 2 to the negative first equals 0.5. That's exactly what this says. All right, now in these bottom 4 down here, we're going to go from log to exponential, right? So again, using my circle of life, I can rewrite this in its exponential form and say 2 to the 5th power equals 32, just like that. Right? And these are equivalent expressions. They're the same thing. Exponentials are logs. Logs are exponentials. Okay? They're just written differently. All right, so we're going to do the same thing here, right? Base is A. Right? What power is it being raised to? B. And what does it have to be equal to? 6. Okay? Same thing here, right? Base is 10. We're raising it to the 2nd power. And 10 to the 2nd power must equal 100. The last one here, base is 7. We're raising it to the x power, and it has to be equal to y. All right, guys, that's it for today's video. Give the practice problems a try. Make sure you know the circle of life. It is the circle of life for a reason. It's going to be used in practically everything we do from here on out. So get familiar with it. If you have questions, let me know in the Zoom chat. Have a great day.